Okay, this is my first attempt for standard 2.3. I decided to do problem 2.13, which asks for a spin 1 system, show by explicit matrix calculation that the spin component operators obey the commutation relations in equations 2.96. First off, to define just the commutator of two operators, we show below right here. Commuters of the operators A and B is just equal to A times B minus B times A. Just general knowledge, if the commutator is equal to 0, then we can say the operators commute, and if they do not equal 0, then we say that they don't. The equations we are asked to verify are listed here below. Basically, if we commute Sx and Sy, we should get I h bar Sz. If we commute Sy with Sz, we should get I h bar Sx, and if we commute Sz with Sx, we should get I h bar Sy. Just as a reminder, the matrix notation for Sz is it is h bar over 2 times h bar over 2 times the matrix 1 0 0 negative 1. The matrix notation for Sx is h bar over 2 times the matrix 0 1 1 0, and the matrix notation for Sy is h bar over 2 times 0 negative I 0. First we'll verify the Sx that commutes with Sy is equal to I h bar Z. Here we simply plug into the formula up here and multiply through. We see basically we can pull out an h bar squared over 4 from all the terms, and then we just multiply our matrices together using basic matrix multiplication, and we get h bar squared over 4 times the matrix 2i 0 0 negative 2i. We can then pull out a 2i, and we'll get I h bar squared over 2, which is equivalent to h bar I Sz. Again, we'll do the same process for Sy Sz. We go through the same steps, and we get down to here where we have h bar squared over 4 equals 0 2i 0. Again, we pull out the 2 and the I, and we get h bar I is equal to Sx. The last one's a little bit trickier. We go through the steps, and we get down to this matrix h bar squared over 4 times 0 2 negative 2 0, but we want it to be in terms of Sx, which is but we want this to equal I h bar Sy as shown below. In order to do this, we pull out the 2, which gives us h bar squared over 2, and then we turn the negative 1 and 1 into I squared and negative I squared, which then we can pull out the I, and we get our Sy matrix. And that is it.